What does that mean? You take any node that this node communicates with, they communicate back and forth. Do you agree?
Yes, I said this essentially brings the question that you just I mean you refined my question to that question, like all we can separate a Markov chain in terms of transient and recurrent states.
So no, that's what I'm trying to prove, right? I'm trying to
Yes.
prove that this is not possible.
Yeah.
I'm saying all of them are transient, but in a communicating, see, you have a communicating class, and I'm assuming that there is one, all of the nodes are transient, but one. There's one node which is not transient, it's recurrent. Now I have to arrive with a contradiction, right? How will you arrive with the contradiction if you assume that there is one node which is transient, recurrent? If this is okay, intuitively, let's look at this. If this is recurrent, what do you mean by that? If you let this Markov chain run, the Markov chain will visit this state infinitely often. Do you agree? Do you agree?
Yes, sir.
If you run it forever, it will reach this, it will visit this state infinitely often, right? So whenever it visits, of course, there is some path like this, right? Because it's in a communicating class. It will communicate with one of the nodes in communicating class, right? Do you agree? Back and forth. So if it visited this state infinitely often, a fraction of the times it would have visited the states in the communicating class also, right? All the nodes in the communicating class. Do you agree? Do you agree with this?
All the nodes are rest of the nodes are transients, right? So
that contradicts the assumption that it's all of them are transient, right? It cannot happen. So therefore, you cannot have one recurrent and others transient, or multiple recurrent and multiple transients in a communicating class. Either all of them should be recurrent or all of them should be transient, right? So now what we have proved, we have assumed that all of them are. So we have proved that if node is recurrent in a communicating class, all the nodes should be recurrent. Similarly, you can prove transient, right? If all of the nodes and if one node is transient, all the nodes should be transient. Recurrent also you can prove similarly. Okay. Can you write the formal proof? So I want you guys to write the formal proof. It's not difficult. Okay, just building upon whatever I explained. Contradiction. Is that fine? Yes or no?
yes, sir.
Yes, sir. Yeah.
Okay, fill this. I mean, it's a fun thing to do. Okay. So now, if you have a state or a Markov chain, so essentially, if you run the Markov chain, you will go back and forth, wander from one state to the other. Some of the states are visited infinitely often, some of them are not, and so on. Right? Now, supposing, let's say, if you take a state I, okay, assume that you can start at I and you can come back to I with some non-zero probability after n.